Okay guys, welcome back. Today's lesson we're going to focus on another form of erosion, and that happens at coastlines around the world. Here's a beautiful picture of a fjord in Norway. They have coastlines there. They often look different than the coastlines we're used to, but nonetheless they're coastlines. So first, waves, ocean waves that is, they erode and they change the shoreline through various ways, and one of those ways we're going to focus on is the longshore current. At coastline, waves and currents act as agents of erosion, and they create all kinds of cool and interesting features. You can see in the bottom left picture here, these are headlands. Headlands generally stick out into the ocean, and spits, they also stick out in the ocean, but they're created more by something called a longshore current, and we'll get into all that in today's lesson. So first, we should really understand how ocean waves travel. So if you look at this short little applet, you'll see the beach ball, and it's moving up and down. It's not really showing exactly how it would move. It would kind of move forwards a little bit, then downwards, then backwards, then back up. So the point of this is that the water itself doesn't move necessarily towards the shore as much as you'd think. What's really moving towards the shore is the wave energy. So the energy moves, and the medium that carries the energy is the water. Okay, the next video clip, this shows an ocean wave traveling towards the shore. And as you see the wave get closer and closer to the shore, it starts to get literally closer together. One crest gets closer to another crest. And the way it works is that as the wave height becomes about 1/2 the wave length, I know this sounds confusing at first, the bottom of the wave starts to feel the bottom of the shore, the sand underneath. And that slows that bottom of the wave down, whereas the top is unimpeded for the most part, and it keeps rushing forwards. So the wave starts to tilt, and this causes the crest of the wave to start to build in height as the wavelength shortens. And then eventually, it can't do that anymore, and gravity takes over, and in the surf zone, the waves break, and they usually break up onto the beach. Speaking of breaking waves, you can see that first picture. This is the spilling wave. So it's gathering height, and eventually it cannot hold itself like that anymore as its forward motion slows down. And that's when the wave starts to plunge. And you can hear that at the beach. When the waves are big enough, they make a loud sound. This picture just shows some wave-cut terraces. This shows where sea level at one point used to be. And each terrace, each change in elevation here, was a previous shoreline. And this can happen for a few different reasons. Perhaps you could stop the video here and you could figure out what might make the wave-cut terraces at such higher elevations compared to where the sea level is in this picture now. All right, this right here I'm going to skip past. We'll talk about this in class. Let's move right on to beaches. All right, hopefully everyone here has been to the beach, but remember, beaches contain a foreshore and a backshore. The backshore is where we hang out, we throw the frisbee around, play volleyball, catch some rays. Berms are left by the tidal deposition and erosion, and they sit higher up on the beach. Here's a berm right here, and another berm right here. And the dunes, you could actually consider a berm almost, and you see the beach grass there growing in the dunes, holding it together. And everything below the low tide level is usually underwater. And then the beach face is between low and high tide level right here in this area. And you can see, and if you go to the beach, you can see that people often put their beach chairs and their towels and things in that zone where the high tide can actually reach, and at some point throughout the day they have to move their stuff up farther up the beach or else it gets wet. Okay, really important slide here to pay attention to, the longshore current. Now, when most waves hit the beach, they don't hit straight on, exactly perpendicular to the beach. They usually come in at a slight angle or a steep angle. And this angle is going to create this longshore current. And what that means is all the sand is going to be moving in one direction down the beach over time. So in this picture, the way that happens is this wave and this wave are going to approach the beach at an angle, and it's going to push the sand grains and everything else, the shells too, up at an angle, and that's the swash. And then gravity takes over and the wave comes straight back in the backwash. And this process repeats all day. And it keeps moving those sand grains down the beach in this case. And that can create all kinds of features, like, for instance, those spits we talked about before. So the longshore current. And it also takes away a lot of the sand up the beach. And so this is where erosion is really seen with beaches, or the longshore current. All right, let's take a look at this one. Watch it happen, if it'll let me. And I don't think it will. So it's just moving by itself. Let's watch. Longshore current. It's coming in at an angle. You can see the arrows on the beach where it swashes up and then backwashes back. But it's all moving at a slight angle. And in this picture, it's moving to the upper left. So the beach sand is like almost like a river of sand moving in that direction. Here's a photograph in the picture to the left. You see the longshore current. So the waves are coming in at this angle. You can kind of see them in the aerial photograph. And they're pushing the sand up in the swash, and then the backwash, it comes back like this, and it keeps repeating. And overall, the sand is moving down the beach this way. Like I said, a river of sand. Now this next picture here on the right, this is just a little side note for those of you who spend more time at the beach. Rip currents. Often there'll be offshore sandbars, just a few hundred yards or maybe just 100 yards or so off the beach. And these sandbars can sometimes have breakthroughs from water currents. And in those breakthroughs, when the water swashes up and then backwashes back, that current moving back out to sea can be very, very fast. And if you're not a strong swimmer and you don't know what to do, you can get caught out and carried far away from the shore and drown. So one of the secrets to getting out of a rip current is to swim parallel to the shore. Swim away from the rip current. And then it will eventually subside and you'll be able to swim back to shore. So hopefully you'll remember that. Okay, this question here says, which direction is the longshore current carrying sediment? And if you look at some of the features in this picture, you'll see here there is a spit and there's a jetty here with some sand piling up around this back side like this. So I think the thing that gives it away the most is the spit, because it's going to be carrying the sand in this direction, and that sand is getting wrapped around. So the longshore current could be coming in like this, washing that sand up, backwashing, washing up, swash, backwash, all the way, and it keeps moving this direction. Same thing over here, it's getting moved up against this thing called a jetty, and that's preventing the sand from going any farther. Bays. Bays are inlets where wave energy is spread out. You can see the nice curve in this picture, the bottom left from Hawaii. And that energy is spread out so much that instead of sediment being eroded, it gets deposited because the water is slow there, it's more gentle. And in this applet, let's see if we can watch that. So here we see the longshore current moving sand across the bay, forming a spit on the other bay. But you get the idea what bays look like. They're curved inwards. They dissipate the energy. And you can also see this nice sand feature, a bay mouth bar and a spit forming. Let's play it one more time so you guys can get the idea. So it completely covers that bay, forms a bay mouth bar, and now we have our spit as the sand moves from the longshore current down the beach, in this case to the lower right. There is a beautiful photograph of a spit. So in this picture, the longshore current must have carried the sand in this direction, and it's wrapping it around there. And perhaps it won't go any farther because there might be strong currents in this direction or in the opposite direction. Perhaps there's tidal flow that moves just too fast to keep that spit there, and the sand gets eroded away, so it will never go across. It all depends on different factors. Ah, there's a spit with an island on the end. They call that a tombolo. Yeah, let's take a quick look at this. Formation of a spit. We can see the beach sand getting moved by the longshore current, in this case to the right, and it's moving farther out. That calm water behind it starts to fill in and accumulate. That forms a marsh, perhaps from mud flats. And some grass grows there. The spit keeps moving, curling around, and the wind is pushing it in that direction. So that whole area back there could become a marsh with creeks. You can see it's almost going to close off this river, but the river's going to keep it from doing that. And there's a narrow inlet now where point A is located. Ah, some vegetation is now growing. This piece of land is now large enough to sustain that. And often, like they say here, they can use these for golf courses, holiday parks, nature reserves, pleasure beaches. And they might put up groins in this area to keep that beach sand from eroding away, but we're going to talk more about that in the next slideshow. Moving on. Here's a wonderful picture of a spit. And this is actually a modified moraine, glacial moraine from the last ice age. But you can definitely see at the tip of Cape Cod, up by Provincetown, how it's curling around. There's a nice spit there. There's also a spit right down here in Monomoy Island. And you can see some spits in Nantucket. And maybe a little bit in Martha's Vineyard, but it's tough to see it there. And that is it. Hopefully you guys learned a little bit about beach erosion today.